In this module, our topics will be carbonyl-containing compounds, molecules that differ by only their spatial arrangement, and our first class of biomolecules known as carbohydrates. Let's focus on the carbonyl group. The carbonyl group has a carbon-oxygen double bond, and due to the electronegativity of oxygen, there are partial positive and negative charges, partial positive on the carbon, partial negative on the oxygen. The carbonyl group in itself is not a functional group. It's a member of the following functional groups. There are aldehydes that have an alkyl group and a hydrogen on either side of the carbonyl, ketones that have alkyl groups, the same or different ones, on either side of the carbonyl, carboxylic acids that have alkyl groups, carbonyls, OH groups, acyl or acid halides, alkyl group, carbonyl, and one of the halogens, fluorine, chlorine, bromine, or iodine, acid anhydrides, which have alkyl groups, carbonyl groups, an oxygen bridge, another carbonyl, and the same or possibly a different alkyl group. Esters have an alkyl group, the carbonyl, an oxygen, and either the same or a different alkyl group. A cyclic ester is known as a lactone, so the two alkyl groups are connected in a ring. An amide has an alkyl group, the carbonyl, and then a nitrogen-containing group, and a lactam is a cyclic aldehyde. There are trivial names attached to many carbonyl compounds, like benzaldehyde, which has a benzene group as the alkyl group, acetaldehyde, and when we have a ring connected to an aldehyde, we name it as the ring, cyclohexane in this case, added to the name carbaldehyde. When naming carbonyl-containing compounds like aldehydes or ketones, we use the longest carbon chain for the base name that contains the carbonyl group. We number the position of the carbonyl, usually with the lowest possible number, and if there are more than two carbonyl groups, the one furthest from the end of the chain is given the term oxo and numbered. So here's a practice. Here's a couple of compounds that you can try in your hand at naming. Don't forget the stereochemistry and the inclusion of the term cyclo for a ring. And there are the names. Remember the base name, ONE ending for ketone and AL ending for aldehyde. A little more practice here with trivial names. Paranitrobenzaldehyde means the nitro group is opposite the aldehyde group on the ring, and then there's cyclopentyl acetaldehyde. Here's some ketones to practice with. The substituent names come first, lowest possible numbers, and the position of the ketone, 3-pentanone in the first case. And when we have a ketone on a ring, we automatically give it the number 1 position. Some reaction chemistry. Remember that aldehydes result from primary alcohol oxidation, but usually the reaction doesn't stop at aldehydes, but continues all the way to the resulting carboxylic acid. So oxidation of primary alcohols usually goes to that carboxylic acid. Secondary alcohols, on the other hand, stop at ketones. There's no further reaction at that point. The opposite of oxidation is known as reduction. This is usually done by adding hydrogen gas. And remember that in these cases, a catalyst is required, usually a precious metal like palladium or platinum. So aldehydes are reduced to primary alcohols and ketones are reduced to secondary alcohols. Other groups also add to the carbonyl, and many of the resulting additions yield alcohols, usually tertiary or secondary alcohols. Sometimes these reactions can occur reversibly. By adding one alcohol group to a ketone or aldehyde, we produce molecules known as hemiacetals, where connected to a single carbon, we have an alcohol and an ether group. If we add 2 alcohol groups, we make what are called acetals. These are reversible reactions and are usually used in an extended synthetic procedure to protect the ketones or aldehydes temporarily. Because these are equilibrium reactions, we can then revert and reform the carbonyl-containing compound.